Mr. T here with a calculus tutorial on finding the area under curves using the fundamental theorem of calculus. In our particular example, our bounding function is x squared minus 5x plus 6, and we are also bounded by the x-axis, which is the line y equals 0, and on the left and right by two vertical lines, x equals 3 and x equals 5, and we're trying to find the area in that enclosed area, or enclosed region. To use the fundamental theorem of calculus, we need to make sure that this function is continuous on the interval between 3 and 5, and we know quadratic functions are continuous. Also, in terms of setting up the problem, we need to know whether there are any x-intercepts between 3 and 5. If there are, we have to set up multiple integrals. So if we factor this to find the x-intercepts, we see that our x-intercepts are at positive 2 and 3, so they are not in the middle of this interval. So we can solve this problem with a single integral. So let's set up our problem. And since we don't know if this is above or below the x-axis, we might get a positive or a negative answer. So just in case, we'll take the absolute value of this because area is always positive. Now, using the fundamental theorem of calculus, we are going to find the antiderivative and evaluate it at 5 and at 3 and subtract those two quantities. So if we take the integral first to find the antiderivative, we get x cubed over 3 minus 5x squared over 2 plus 6x using our basic integration rules, and again we have to evaluate that from 5 to 3. So we plug in. So 5 cubed is 125. 5 squared is 25 times 5 is 125. And 6 times 5 is 30. Minus, then we want to put this entire quantity in parentheses so that we handle the distribution of the minus sign properly. So 3 cubed is 27. And 5 times 9 is 45. And 6 times 3 is 18. Now if you need to, you could use a calculator or whatever. This simplifies here to 55/6. And this simplifies to 9/2. And if we subtract those, we get 14/3. And since that's positive, we have our answer. That's our area in square units. So let's look at a picture of what we just did. This is the graph of our function, and x equals 3 is here, and x equals 5 is here. Oops. And we just found the area in this region here to be 14/3 square units. Thank you. Hello, Mr. T. This is our second calculus problem dealing with area under a curve using the fundamental theorem of calculus. We can see for this example here, our function is a rational function, x over x squared minus 1. We need to ensure in our interval here between 2 and 4 the function's continuous. Now this function has discontinuities at positive and negative 1, vertical asymptotes, so those are not inside of our interval. So our function is continuous otherwise, so we're okay with the continuity part of our definition. And our only x-intercept would be at x equals 0, so we know that in the interval from 2 to 4 the curve is all on one side of the y-axis. So we can set up our problem as a single integral. And again, I'm just going to put, just to be safe, absolute value here in case if this function is below the x-axis we would get a negative number, and we can't have negative area. We'll deal with that at the end to see what we come up with. So now we need to integrate this so that we can apply our fundamental theorem of calculus. So here we have an expression in the denominator, so we're going to use integration by substitution. So let's try letting u be our denominator. So we're trying to use the rule u prime over u. So for that rule to work, our u prime would need to be the derivative of what we chose for u, which would be 2x. So I have the x here, but we need to adjust it, so we need that to be 2x, so we have to put the reciprocal out here so that we have not changed the problem, because 1/2 times 2 gets us back to the original problem. So now we integrate. Now you may remember that the integral of u prime over u is the len of the absolute value of u. So we get here the len of the absolute value of x squared minus 1. And we need to evaluate this between 2 and 4. And again, at the end, if this comes out to be a negative number, we will take its absolute value. So to calculate here, we have the len of now 4 squared minus 1 is 15. I forgot here we have our constant out front, so this should have been a 1/2 here. So we have the len of 15 minus, now we need to use our lower limit. 2 squared is 4 minus 1 is 3, the len of 3. We can use our logarithm properties to combine here. So we get the len of 15 thirds, which would be the len of 5. Now this would be our exact value if we wanted an exact answer. If we use a calculator here, we get approximately 0.805, and that was a positive answer, so we have our area in square units. So let's look at what this graph had looked like and what we just found. So this is the graph of our function, and our integration bounds were at x equals 2, which is here, and x equals 4, which would be about here. And again, we just found the area in this region in here to be about 0.8 square units. Thank you, and see you on our next problem. Hello, Mr. T, and another calculus tutorial. This is our third problem on area under the curve. Again, we're using the fundamental theorem of calculus to find those areas. In this problem, we have our function shown here, and we are finding the area bounded on the left and right by x equals 1 and 3, and on the bottom by the x-axis. Again, to apply the fundamental theorem of calculus, we need to ensure that this function is continuous on our interval, so our only discontinuity is at x equals 0, which is outside of our interval. And there are no values of x that will make the function equal to 0, so we have no x-intercept, so we can use a single integral. So again, let's set up our problem. Oops, I'm having trouble spelling area today. So we are integrating from our left bound is 1 and our right bound is 3. So we are looking to integrate this using our rule u prime times e to the u. So let's just slightly rewrite our problem. So e to the u, so our u is 3 over x, which is 3x to the minus 1 power. So our u prime would be negative 3x to the negative 2, which would be negative 3 over x squared. So we have the 1 over x squared, so we need to put a negative 3 in the numerator, and we will undo that by putting our negative 1/3 on the outside. Now again, at the end, if this answer happens to come out to be a negative number, that's going to indicate that our area was below the x-axis, and we'll take an absolute value. We'll worry about that when we get to the end. So now if we apply our integration rule, we have our constant out front times, and now we have u prime times e to the u, so our integral is just e to the u. And we need to evaluate this between 1 and 3. So now we have negative 1/3 times, now we plug in 3, so we have 3 over 3 is 1, so we have e to the first power, minus, and if we plug 1 in, 3 over 1 is 3, e cubed. That would be our exact value. Now e cubed is bigger than e, so this number is negative. Negative times negative is positive, so we have a positive number here. If we want to put that into a calculator, we can get an approximate value of 5.8. So the area of this problem is 5.8 square units. Let's look at what we just accomplished. So if we look at a graph of our function, we were finding the area from x equals 1 up to our curve, and it intersected up above the graph, and x equals 3, which is here. So again, we just found the area in this region in here to be about 5.8 square units. Okay, thank you.